rounding out our track today with a bang as we take on breaking data barriers. Please welcome Jorge, co-founder and CEO of MindsDB, to talk about the company's inception as an open source in-database machine learning platform. Jorge, over to you.
We believe that data and leveraging data to make informed decisions is the best way to get a competitive advantage. And machine learning plays a crucial role in this process. MindsDB and SingleStore together enable companies to accomplish exactly that. My name is Jorge Torres, and I'm very excited to present to you this partnership that we have with SingleStore and MindsDB, and a little bit about MindsDB as a company. We started MindsDB as an open source project back at UC Berkeley in 2017. Then we went to Y Combinator in 2020. We raised a decent seed round to make sure that our open source project, which is a very mature open source project, got to the level of maturity that could be used by large organizations. And we're one of the most promising AI companies by Forbes, truly because this different idea that we have about making sure that companies can get to production as fast as possible when they actually have a machine learning problem in mind. And this of getting into production as fast as possible is possible because of the fact that if your data is in a database, you've already accomplished the most difficult part of any machine learning task, the data preparation task. Now, in a data-centric approach, the database is the heart and the beating heart of your infrastructure and of your decision-making process. Connected to your database, you have the analytics, the applications. You already figure out how to stream data and pipe data into SingleStore, and you already know how to organize it. So since you've already cracked this very difficult part, the goal of MindsDB is to ensure that you can do the modeling and the deployment in a very similar environment to the one that you have for processing data in the database. So it allows you to do everything in SQL. Let me walk you through a demo that will show this end to end. The way that MindsDB works is that it is a database for machine learning models, yet everything that has to do with data, it delegates to the database, in this case, SingleStore. We're going to connect to our SingleStore database and do some sort of modeling and predictions. Now, in this particular demo, we're going to have house rentals data, and we're going to forecast this into the future. This is a really cool project because it's also a difficult one for machine learning, where you have a time series problem that has a high degree of cardinality, and it's also multivariate. Let's look at the data and explore and see how and why that is the case. So what we have here is data quarter by quarter, and it has some attributes. It has a moving average of the price, which is what we want to predict, but also it has the type, which it can be a house or it can be an apartment, and it has a number of bedrooms. So essentially what we're going to do here is, okay, for a house, roughly in the area of San Francisco, what will be, or in the area of Berkeley, what would be the price in the next following 3 or 4 quarters, taking into consideration all the information that I have of the moving average of all the prices that I can collect. Let's see how we can actually create a predictor for this. The beauty of MindsDB is that it abstracts all the life cycle for machine learning into one single statement. You have the data preparation, which is a query in this case. This query can be as complex as you want. For the sake of this example, it's a simple query, but if you need to do any form of data transformation, you can create this query here, put this query statement here, and that gets delegated to SingleStore. On the other hand, if you want, you can create a view that creates all the transformations in SingleStore, and then MindsDB queries that view. Now, the create predictor statement is similar to that of create a table, and it does a modeling part. And in the modeling part, what you're doing is, okay, I want to do a time series problem that orders by sales date. Essentially, that is the horizon, or that is the column that contains the information in which you're going to order information by. And then this one is a multivariate high partition or high cardinality problem because it has many different, number of bedrooms and number of types of property. And at the end, what you're telling is, I want to order by, group by these 2 attributes, and I want to be able to take into account the last 8 quarters in order to project the next 4. Let's run the statements. For the sake of this demo, I had already trained the model before, but I'm going to run this one. And so we don't have to wait until the model is done training. we can actually look at how the model performed in the last. Let's check out the model that I had trained. Now, what it's telling me is this model has a 52% accuracy across the 4 periods. So like it will get better, or the first result in the first quarter has a very good accuracy. And as the time progresses, the accuracy will drop. Still 55% is good, taking into account that you're trying to forecast something a year in advance. So let's look at how the model was built. This model was built using a neural network, LightGBM and SK-time. And then MindsDB will try those and figure out which one will be the one that performs the best. In this case, SK-time is the winner, and that is how the model was being put together. Now, you may be asking, okay, but what data was put into the model? How do you encode this data? MindsDB gives you this trick, which is the ensemble. You can dive into how that ensemble was built, and you can also experiment with it. You can change how and which parameters you want. Even if you wanted to use only SK-time, or if you wanted to use a transformer, you can specify this capability on the create predictor. But let's look at how the ensemble was put together. So MindsDB realized that the moving average is the type, one of the time series columns. So it's going to encode it as numeric values and code it into another array. The same thing for sales, state, then the type. It realized that, well, you only have 2 categories here, so let's put it a binary encoder. The number of bedrooms, let's do a 1-hot encoder. And then at the end, it decided that it was going to try a neural network, LightGBM array, and SK-time. Well, now, having said that, now you can query the model as if it was a table. Since this is a time series model, you can join it with the data that you have. Let's actually make a query to predict what would be the prices for the houses when the bedrooms are 2 in the next following quarters, and for the date greater than the latest. This is a unique statement to the way that MindsDB does things, which is, well, you actually want to forecast something into the future, assuming that the latest data point is a data point of today, then the latest 4 would be the next 4 quarters. And that is crucial to forecasting. And we make this simplification. So when you run the query, you don't have to go and fetch the last 4 or the last 8 of properties that are houses and number of bedrooms too. MindsDB does this kind of like organization for you. Let's make this prediction. Okay, and there you have it. Forecasting for the following 4 quarters given the latest information. Thank you so much for being part of this demo, and looking forward to see what all of you can do with MindsDB and SingleStore. And before we're done, some resources for you. You can get started with SingleStore. There's a 500 in free credits today. Follow these links. Also, there's a very comprehensive guide for anyone that has any questions about SingleStore. Go to the SingleStore download and start using the product. And for MindsDB, you get the cloud account for free as well. We, of course, are open source project. You can deploy it on your premise, but you can go to cloud.mindsdb.com and you can get started within a few clicks. Join our community, GitHub, Slack. Looking forward to see you there. Thank you.